In order to understand how binary addresses work, let's take this small example. Okay, I have just taken a real life scenario so that it will be a little bit more interesting. Okay, let us assume we have four streets. Okay, streets. A city has four streets, and I'm naming the streets as street 0, street 1, street 2, and street 3. Okay, and every street has two houses. Okay, it is just an example. Every street has two houses, H0, H1, okay, H2, H3, H4, H5. In case if there are four streets and if each street has two houses, then there will obviously be 8 houses, okay, and 8 houses and numbering from H0 to H7. And assume that every house has two floors, okay, every house has two floors, and I'm naming the floors as F0 till F15. Since there are 8 houses and each house has two floors, there will be a total of 16 floors, okay, and I'm naming the 16 floors from F0 till F15. Now let us assume, so one thing is clear, in this city there are a total of 16 floors, right? 16 floors are present in this city. See, a city has four streets, every street has two houses, every house has two floors. So from this I can say that this city has exactly 16 floors, okay. Now what I am going to do is I am going to give a unique address to every floor, okay. See, there are 16 floors. Now in order to number 16 floors, how many bits do we need in case if I want to address in binary, which means I need to give an address, an unique address to every floor. Okay, I need to number it in binary. For example, this floor should take 0, this floor should take 1, this floor should take 2 in binary. Now, in order to, we have already seen that in order to address 2 power m, say 2 power m floors, we need m bits. Right? In order to address 2 power m floors, we need m bits, which means in order to address 16 floors, we need 4 bits. Right? See, starting from 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0 1 1 0 0 1 1 1 1 0 0 0 1 0 0 1 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 1 1 1 0 1 1 1 1. Okay, so I used 4 bits to address all these 16 floors. For example, in case if I want to refer this floor F7, I will use the address 0111. Okay, 0111 is nothing but 7, right? This is 0. In case if I convert this binary number into decimal, it is 0, it is 1, it is 2, and so on, it will become 15. Okay, so this is fine. Now how can this address be used? Okay, see, let us assume I am taking this address, okay, floor number 9, 1001. This is the address of floor 9, right? Now how I can use this is, see, I can split this address into parts. For example, here there are 4 streets, right? Here there are 4 streets. Now, and in order to number 4 streets, how many bits do we need? In order to number 4 streets, we need 2 bits, right? Because with 2 power m, in order to address 2 power m floors, in order to address 2 power m streets, we need m bits, right? So since we have 2 power 2, which is nothing but 4 streets, we need exactly 2 bits, right? In order to address 2 power 2 streets, we need 2 bits. And so I am taking the first 2 bits of this address in order to address the street. Okay, it is actually indicating the street number. So I am taking the first 2 bits in order to indicate the street number. Okay, since I have 2 power 2 streets, I am taking 2 bits in order to number the street number. Similarly, how many houses do we have? We have exactly, see, every street has exactly 2 houses, right? Every street has exactly 2 houses. Every street has exactly 2 houses. So what I am going to do is, in order to number 2 houses, we need exactly 1 bit, right? In order to number 2 houses. See, 2 power 1. In order to number 2 power 1 houses, we need exactly this 1 bit. Okay, we need 1 bit. And so I'm going to take this 1 bit in order to indicate the house number. This is indicating street number. Okay, first 2 bits, and this is going to indicate house number. This 1 bit. Okay, and every house has exactly 2 floors, right? Now, in order to indicate 2 power 1 floor, see 2, I can also write it as 2 power 1, right? 2 power 1 and 2 both are same. Now, in order to number 2 power 1 floors, I need exactly 1 bit, right? So, I am going to use this 1 bit in order to indicate the floor number. Okay, so this 1001 can be seen in two ways. Okay, one thing we can see is it is actually indicating 9, right? See, this is 2, this is 1, this is 2, this is 4, this is 8. Now, in case if I convert this binary number into decimal, it is actually indicating the number 9. So, what I can do is, what I can tell is, this is the address of floor F9, right? This is the address of floor F9, or this is the address of 9th floor starting from 0, right? I can tell that. Another way I can interpret this address is, I can also say that this address is actually indicating street number 2's. Street number 2 is nothing but S2, right? See, this street can also be numbered as 00, 01, 10 and then 11, right? And since this is 10 or street number 2, I am going to this street. Okay, now within this street I am going to see the zeroth house. Okay, within the street I am going to see the 0th house. See, within this, though this is H4 starting from H0, this is the 0th floor of this street, right? This is the first floor of this street. Since we have the number 0, I am going to the 0th floor, right? Now within this house, 0th house, okay, I am going to the 0th house. Now within this house, which floor should I go? That is being indicated by the last bit. Okay, this is indicating first floor, it is not indicating 0th floor, right? So what I am going to do is I am going to the first floor. Okay, and so I reach the exact 1001. Okay, so what I can tell you is this 1001 can be interpreted in two ways. This one thing I can say is this is indicating floor number 9 straight away, or this can be interpreted as this is a floor which is present in second street's 0th house's first floor. Okay, it is a little bit difficult. So what I want to tell you is we can interpret it in two ways. One thing we can say is this is indicating floor number 9, or I can say this as this is indicating second street, and within the street I am going to the 0th house, and within the 0th house I am going to the first floor. Okay, that is what this is indicating. So this is the way to actually partition the binary numbers and look it in a different way. Okay, now answer me one question with regard to this. Assume that we have exactly 4 partitions. Okay, we know that what is meant by partition. We know that this is our RAM. Let us assume this RAM has been divided into 4 partitions. Okay, this RAM has been divided into 4 partitions. This is partition 0, partition 1, partition 2 and partition 3. And every partition has exactly, let us assume it has exactly 4 bytes. Okay, so this is just an assumption. Okay, generally it will be very high, but I am just taking it just to make you understand the concepts better. Assume that every partition has exactly 4 bytes. Okay, it has been divided into 4 bytes. Similarly, this will also be divided into 4 bytes. Now, assume that every byte is given a unique address. Okay, I can also say this as byte addressable system. Okay, we will see that a bit later. Okay, what is meant by byte addressable system, but anyway I am giving a rough idea. Byte addressable system means every byte which is present in our RAM will be given an address. Okay, we also have something called as word addressable system. We will see that later, but right now I want to assume that I am going to assume that every byte will be given one address. For example, this will be given an address of 0, this will be given an address of 1, 2, 3, and this will be given 4, 5. Okay, likewise I am going to do. Now tell me how the addressing will look like. Okay, see, our RAM has been divided into 4 partitions, and each partition has been divided into, each partition has exactly 4 bytes of data, and every byte in which is present in our RAM will be given a unique address. Okay, now how this will be present? See, we have exactly 4 partitions, right? We have exactly 4 partitions, and each partition has exactly 4 bytes of data. So there are a total of 16 bytes of data, right? There are a total of 16 bytes which is present in our RAM. See, this is just an example, okay? We have exactly 16 bytes which are present in our RAM. Now, we have already seen that it is a byte addressable system, which means every byte will be given a unique address. Okay. Now, in order to address the 16 bytes, since every byte is given an address, the 16 bytes will be given 16 addresses, right? In order to have 16 addresses, how many bits do we need in binary? It is exactly 4, right? In order to address 2 power 4 bytes, 2 power 4 is 16, right? We need exactly 4 bits, right? So our address will have exactly 4 bits. Okay, I'm going to take, this is first bit, this is second bit, this is third bit, and this is fourth bit. Okay, there are exactly 4 bits. Now how these 4 bits will look like, that is very easy, right? How these 4 bits will look like is very simple. It will start from 0 0 0 0 0 0 0 1 0 0 1 0 and so on. It will go on till 1 1 1 1. Okay, there is no problem with that. Now how this will be divided? Okay, how this will be divided? See, we have exactly 4 partitions, right? We have exactly 4 partitions. Now in order to indicate 4 partitions, we need exactly 2 bits, right? This is partition 0, this is partition 1, this is partition 2, this is partition 3. So in order to address 2 power 2, which is nothing but 4 partitions, we need exactly 2 bits, right? We need exactly 2 bits. So what I'm going to do is I'm going to indicate, so this first 2 bits will actually indicate the partition number. Okay, this is going to indicate the partition number. Now every partition, within a partition or every partition has exactly 4 bytes, right? This has also 4 bytes. This has 4 bytes. Now in order to number 4 bytes, how many bits do we need? In order to number 4 bytes, we need exactly 2 bits, right? So these last 2 bits is actually going to indicate the byte number. Okay, so what I want to tell you is, we had a total of 16 bytes, and since we are numbering every byte or addressing every byte, I told that in order to address 16 bytes, we need 4 bits. Now, since there are 4 partitions, we need exactly 2 bits to address a partition. So I have taken the first 2 bits to indicate the partition number. And since every partition has exactly 4 bytes, and in order to address 4 bytes, we need 2 bits, and so I have taken the last 2 bits in order to indicate the byte number. Okay, now you take any number. For example, if you take a number of say 0011, what does it indicate? I need to go to the 0th partition, right? 00 is nothing but 0. See, this is 00, this is 01, this is 10, and this is 11. You can convert it. 00 is nothing but 0, 01 is nothing but 1, 10 is nothing but 2, and 11 is nothing but 3. Now this is indicating 00th partition or 0th partition, and so I'm going to this partition. Fine. Now within this partition, I need to go to the byte number 11. What is 11? 11 is nothing but 3, right, in decimal. So this is 0th byte, first byte, second byte, and this is third byte. And by using this address, I am actually indicating this byte. Okay, this byte, which means this third byte. So in a similar way, we can actually use the binary numbers. Okay, this is the basic idea of paging. Okay, in order to understand paging and segmentation, this is a very important concept. Okay, fine, let's see this.